Welcome to today's video. Today we'll be talking about approximating area using Riemann sums. And we're specifically going over left hand, right hand, midpoint, and trapezoid. That will most likely be on the AP test. So we'll start with our left hand Riemann sums. So your left hands will be, let's just say you have a graph and it's going to be, just draw a sketch of a graph. Something like that. It's a weird looking graph, but it'll do. Let's just give ourselves a little table. So we'll have our x values and our y values. So this is at 0, 1, 2, 3, 4. This is at 2, 3, 3, 1, and 4, 0. So it's some sort of function. I don't know what function it is, but it has some curvature to it. And so now using a left point or left hand Riemann sum from, we'll say using a left hand Riemann sum of this function, which we'll call f of x, so call that f of x, from 0 to 3. And this is going to be our left hand. So we're going to do a left hand Riemann sum from 0 to 3. So we'll draw ourselves a fancy rectangles. Left hand, the rectangle needs to have the function, or the rectangle height, be based off the point of the left. I just realized we don't know it, so we'll just say this is going to be 1 and looks like 2.5. We'll just go an even 2.5, just for the purpose of it, so you understand how to do it again. So from 0 to 3, this is 0, 1, 2, 3. And they usually will tell you how to split it into equal sections. So we'll say into 3 equal sections. So you know how to do your bases and all that stuff. So all you have to do is basically times the base, or the height, or times the height times the base, which all of these are going to have 1s. So, but since it's based off the point 0, all you have to do is 0 times 4. So this would be 4. This would be 2.5 for 1, and 2 would be 3. Of course, it's going to be an over approximating the area, because you can see where the rectangle is outside of the graph. So all we have to do is just add these together. 4 plus 2.5 plus 3 equals 9.5 units. Quantity squared. So that's how you would find area under function, approximating it, of course, of this function. That's the left hand. So let's go to a right hand. We'll just use our fancy handy dandy. This will be just a rough sketch. We'll just say this graph is x squared. Then we can just use the table, because sometimes they'll give you a table to do it off of. So let's just say the function is f is x squared, is f of x. And that will be what our function approximately looks like sketching it. It's not really a good sketch, but you know, it works. So we'll say from approximate the area of f of x from from 1 to 3. So should be from here to here. 2 equal sections, so we can just use the base of 1. Is usually simplest. And we're going to do right hand. So let's just put down the points. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So knowing that, we can use the right hand of it. So technically you'd have to use, from 1 to 2, you'd have to use the second one on the right to figure it out, the right hand. So it overestimates. So the difference between a left hand and the right hand is the left hand, depending upon the function, you'd use the left hand function depending upon what one they're talking about, or the one usually next door to it, to figure out their angle. Because if they're doing from 1 to 3, you want it, and they're doing 2 equal sections, you have to do from 1 to 2 to 2 to 3. So you have to use the third and the second one. So knowing that, this has a base of 1 on all of these, and the height of 4 and 9. 4 times 1 is 4. 9. 4 plus 9 is 13 units squared, approximately. That'd probably be a good thing to include, is it's an approximate area under that, from that region from 1 to 3, using 2 equal sections of right hand. Now let's add on midpoint. So let's just use our x squared graph again, because it's a simple one to use since we still have the table. So let's do a midpoint from this will be our mid point. Riemann sum from 1 to 3. And I don't remember if they asked for how many sections there are, but technically there's only going to be one section. Because if we're going to do it from here and here, so we're trying to find the area under here, we take the middle point, which would be 4, and you go over here and drop it down. can come over here and drop it down. So it's going to be an overestimate, but an underestimate at the exact same time. So it's going to be slightly more accurate on this one. So we know that has a base of, or a height of 4, base of 2, so the area is approximately 8. So it's going to be less than our right one, and it's going to be even lesser with our left one, because if we go even further to the left, it's going to have a less area. Because if we do 1 to 3, it'd be going from 0, 1, and 2. 0, 1, and 2, my bad. So it'd be only doing this point, this point, and this point, which would only be 4 plus 1 plus 0, which is 5. So we had to have a left-hand Riemann sum of 5, mid of 8, and a height of 13. So how do we make this more accurate? We use trapezoids. So let's switch over to a new piece of paper and go to trapezoids. And trapezoids are the most accurate way to approximate an area using Riemann sums. So we'll have our function again. We'll have f of x, and which was x squared. So we have and decent scratch, and it's technically I have to include that. I just realized that, but you know, we'll just do the positive side. So we have 0, 1, 2, 3, 0, 1, 4, 9. We'll just do those 4. So let's see here. Let's do a trapezoid. Riemann sum from 1 to 3. And technically you'll be using 2 equal sections. So we can just use 1 as a base. As a heads up, they'll probably maybe give you like 4, so let's say you have an area from 1 to 3, and they give you 4 equal sections. How would you split this up? So this is 1, 2, and 3. 4 equal sections from 1 to 3. There we go. So sometimes they might give you more sections for, to cover in a certain area, which will cause it to be more accurate. So how would you split this up into equal sections? 1 to 1.5 is 1, 2, 3, 4. So you just split it up in 2 small increments, which will be by half. So this will be 1.5, even 2.5. But to keep it relatively more simple to calculate, we'll just do 2 sections. So it has a base of 1, from 1 to 2, 2 to 3. So, we'll probably should have made this a little better. Basically, you'd be doing trapezoids, which would line up with the curve more better than it would with a rectangle or a rectangle, because that'd be calculating this little area here or here better. So in order to do that, you have to know the sides on the left and the right. So you'd have to know from here to here and from here to here. You have to know 2 heights, because the area of a trapezoid, if you remember, is base 1 plus base 2, there we go, times the height over 2, or just half both bases added together times the height. So knowing that and knowing our bases or our height as 1 and your bases as these, because 1 would be 1. So let's just come down here and just do it for 1. Do it for both. Let's just say this is from 1 to 2 and this is from 2 to 3. So you can see it more easier. Then you have the graph come like that and like that off of it. So you have a base of 1 on both of these. Your height for it on this side, because it's coming off of f of 1, which is just 1, or just 1 squared. This is coming off of 2 squared, or f of 2, so that'll be 4. This will be 4. F of 3 is this point, and this will be 9. So now knowing that, you add these two together, times by the height, divided by 2. So 1 plus 4 is 5, times 1 is 5, divided by 2 is 5 halves, plus 4 plus 9, 13, times 1 is 13, 13 over 2 is 13 over 2. And then you add them together, 13 plus 5 is 18 over 2 equals approximately 9 units squared, which is more accurate than these two compared to our, let's just say we calculated this one as 5 earlier for our left, mid, right. Okay, so slide these two right there. Perfect. Didn't get that. Put that one down. So it's more than this one, but less than this one. But this one is more accurate. This one's more accurate down here because it's calculating this gap right in here. So I know that was a lot to cover in a short amount of time. I hope it was helpful. If you would please like this video, comment down below any other videos you'd like me to do on any topics you'd like me to cover. I'd like to cover a lot of topics from algebra to calculus to geometry to trigonometry to statistics, any of those in between. If you have a topic that you really want me to cover, comment down below of specific topic. Subscribe to this channel, I'd really appreciate it. It'd help a lot, and I'll see you next time.